Hello my dear students in grade 5. Today they will talk about Unit 2, Concept 2, Lesson 8, Factors or Multiples. Let's get into it. But first, we have to study the relation between the LCM and GCF and the product of the two numbers. First, our main rule is the GCF times the LCM equal the product of two numbers that I get for them, the LCM and GCF. For just example, when I say two numbers, one of them is 12, their GCF equal 2 and their LCM equal 60. Find the other number. You see, this rule I will apply it step by step. What is the GCF? I have 2 times. What is the LCM? Equal 60. So 2 times 60 equal the product of two numbers. I have one of them equal 12 times, and I don't know what is the second number really is, so I will give it as a symbol X. So 2 the GCF times 60 the LCM equal 12, one of the numbers times X, the other number which I don't know. Go with it step by step. 2 times 60, drop the 0, and 2 times 6 equal 12. So 2 times 60 equal 120. Equal 12 times a number I don't know. Think with me for just 1 second. What is the number times 12 give me 120? You may all think about it. That's right. According to the multiplication facts, then the number is 10. So the X or the number which I don't know it equal 10. Then the other number or X equal the other number equal 10, and this is the other number. Let's revise it together. First, write the GCF. Second, write the LCM. Write equal the product, that means times one of the numbers 12 and the other number which I don't know it, symbolize it as X. Do the multiplication. 2 times 60 equal 120, and drop the 12 as it is, drop the X as it is, and think about it according to the mathematical facts or the multiplication facts. What is the number times 12 give me 120? And you will find it according to the multiplication facts, it will be 10. Is it clear? Good. Let's get to the next. In the case of the story problems which I use the GCF or LCM, I must get keywords that helps me to find which one of them I will use. For just example, the GCF, we always use it when I divide or distribute any quantity in equal way, or breaking any numbers into groups. This is the cases which I use the GCF, those 3 cases: dividing, distribution equally, breaking into groups, or when I say I will get the largest or the greatest number. And in this case, be careful, because the story problem may be a little bit tricky. Okay? And what about the LCM? I use the LCM when I talk about something repeated. I used to repeat it, or two things occurred at the same time. In those 2 cases, in addition to the least number, in this case I use the LCM. And let's see these story problems. The dimension of a room are 12 and 8 meters, and a contractor wants to tile the room using the least number of square tile. What should be the tile dimension B. One of you will say, I got the least number, so I will use the LCM. And in this case, in a trust, I will say him, that's wrong. Why? And be careful with this. I have a room, just like the room which I'm inside in, and I want to divide this room into a square tiles. The tiles, okay? I wanted to divide it into square tiles. Square tiles that mean which can cover the room that I must get the greatest dimension as I can. So I told you the greatest dimension. The greatest dimension, that means I want to get the GCF. And let's get the GCF between the 12 and 8. Factorize the 12. The 12, any one of you will say 2 times 6. Or any one of you will say 3 times 4. In both cases are good. But don't you ever to write 12 times 1, that you will enter into a loop that you cannot get away from that. Okay? 2 is a prime number, put it in a circle. 6 is a composite number, put it in a square. The 6, split the square into 2 arrows. 6 equal 2 times 3. And those prime numbers, so I put them in a circle and say stop. In the same way, I will do it with the 8. 8 is a composite number, so split it into 2 arrows. 2 times 4. 2 is a prime number, so put it in a circle, say stop. 4 is a composite number, put it in a rectangle and split it into 2 arrows. 4 equal 2 times 2. So, you see, I factorized both of those numbers. So let's write the prime factorization for both of them. 12 equal 2 times 2 times 3. The same way, the 8 equal 2 under the 2, the similar. 2 under the similar fit 2. What about the third one? Should I write it underneath the 3? No, I will write it away, just like this. And let's get the GCF. So circle the common factors. I circle 2 and 2. Okay? I circled both of 2 and 2. So I wanted the GCF. So it means 2 times 2, which equal 4. So the greatest dimension ever I can get it, or I can possibly get it, equal 4 meter for one squared tile. Is it clear for you? Good. Let's get to the next one. The neon signs are turned on in the same time. Both of signs blink as they are turned on. One sign blinks every 9 seconds, and be careful. And the other sign blinks every 15 seconds. In how many seconds they will blink together? Calm down, read it carefully, and think about it. I have two events. One sign blink every 9 seconds. The second event, the second sign blink every 15 seconds. So that means that they blink repeatedly. And I wanted to find out the time that they will blink in the same time. That means two things occurred in the same time. So I will use the LCM, and let's factorize the 9 The 9, as we all know, equal 3 times 3, and the 3 is a prime number, so put it in a circle and say stop. The same way 15. The 15 we all know equals the 3 times 5, and both of 3 and 5 are prime numbers, so put them in a circle and say stop. Let's write their factorization. 9 equal 3 times 3, and 15 equal 3 underneath the 3 times 5. And as we all know in the LCM, drop all the numbers, then multiply. So 3, I will drop it. I have 3 as a common factor. Those, I will choose one of them, 3, and drop the 5. 3 times 3 times 5. 3 times 3 equal 9. 9 times 5 equal 45. So they will blink after 45 seconds. So the LCM equal 45 seconds. Is it clear for you? Pretty awesome. Okay, nice. This is the end of our lesson today. Don't forget to like, share, subscribe. Thank you and see you soon.